Working with equations. Lesson objective: solve 1 and 2-step linear equations. Y divided by 4 minus 1 equals 13. Again, we have two operations: divide by 4 and subtract 1. Following the order of operations in reverse, we want to get rid of the subtract 1 first, and then we'll take care of the divide by 4. So we're going to add 1 to both sides. These cancel. We're left with y divided by 4. Bring down your equal sign. 13 plus 1 is 14. The inverse of divide by 4 is to multiply by 4. These will cancel. But if you multiply by 4 on the left hand side, you got to multiply by 4 on the right hand side. And 14 times 4 is 56. Let's do an example involving the z-score formula. So z equals x minus the mean divided by the standard deviation. If we know that the z-score is 1.96, the mean is 100, and the standard deviation is 15, let's find x. So substituting these values in to this formula, we get 1.96 is equal to x, our variable, minus the mean, which is 100, divided by standard deviation, 15. So our variable is on the right hand side of the equal sign. We need to get rid of the divide by 15 and the subtraction of 100. In this case, we do have a subtraction and a division, and normally we would get rid of the subtraction first, but in this case, this divide symbol, this is sort of like grouping symbols, and that means is we have to compute what this quantity is, and then we divide. So order of operations says you have to do parentheses, grouping symbols first. So for solving an equation, we have to get rid of the 15 because that's division first before we get rid of the grouping symbols. So our first step in this case is we need to multiply both sides by 15. That will cancel and this will cancel, and since we multiplied by 15 on the right hand side, we have to multiply by 15 on the left hand side. 15 multiplied by 1.96 is 29.4, and that is equal to, these are gone, x minus 100. Now this is now a one-step equation. We have subtract 100. If we add 100 to both sides, we will have our solution. These will cancel. We have x, bring down our equal sign, and we have 29.4 plus 100, which is 129.4. That is our solution. And our last example, if we take our z-score and we solve it in terms of x, we will get a new formula, and that new formula will be in terms of x. So when we want to find the value of x and we know z and the mean and standard deviation, this formula will be a lot easier to work with. Let's take our equation. Z equals x minus the mean divided by sigma. Now don't let these symbols throw you. It's the same thing as we did before. What we want to do is we want to get x all by itself. That's what in terms of x means, to get x all by itself. What do we get rid of first, the mean or the standard deviation? Well, because sigma is dividing this whole expression, this is like grouping symbols, so we have to get rid of the sigma first. Since the sigma is dividing the x, we do the opposite and we multiply both sides by sigma. Well, that gives us sigma times z, or z times sigma. It doesn't matter. It's multiplication. These two, it's a product. What does that equal? That equals, well, these sigmas cancel. We're left with x minus the mean. Just like before with the numbers, we now add. So we add the mean to both sides. And we get sigma times z plus mu, or since it's addition, we can say the mean plus the product of standard deviation and the z-score, that equals x. This formula, even though I don't know the exact numbers for these variables, this is a new formula, but it's exactly the same thing as this. One is in terms of x, this one, and one is in terms of z for this one. You will see this formula as we get into the normal distribution, and we want to use this formula when we are trying to find a certain particular value, like a height or an IQ, and we are given a z-score, or we're given a percentile that we can change to a z-score. And of course we have to know the mean and standard deviation. But you'll see examples of that in the future. Thanks for watching.